Hello, everyone. My name is Matt Marsala. I'm a product manager with Pure Software. And in this session, we'll be talking about ways to improve availability, productivity, and agility in complex storage environments. Pure Software has been in the unstructured data management space now for over 27 years, helping our customers to analyze and understand what they have in terms of unstructured data on their storage arrays, as well as helping customers move that data between different platforms and different locations to help drive end user productivity and make that data more available across their environment, as well as increase their agility, their ability to adapt in an ever-changing IT landscape. Let's kick off here with a slide talking a little bit about why Pure. There's many other storage vendors, or software vendors for that matter, in the unstructured data management space. But I want to talk about a few key items that are at our core, things that make us different, that permeate through all of our technology and all that we do. So first off, I want to talk about this notion of real time. Everything that we do, everything our software does is respond to user activity and application activity in the file system in a real-time fashion. We're not relying on constant scans of the file system to try and understand what's going on. We don't have to compare monolithic snapshots between different or on the same volume to understand what's going on. We have this real-time capability, this integration with various NAS platforms that act as our eyes and ears. As users are making changes, we're able to react to that information in real time. Second item up on the list here is the notion of cross-platform. I mentioned earlier we have integration with various enterprise NAS platforms, from Windows file servers, Nutanix files, Dell EMC platforms, and NetApp platforms. But the benefit of having all these integration points is that our software is able to move data between these different platforms in a heterogeneous environment. We all know that hell will freeze over long before NetApp will ever replicate natively to an EMC Isilon cluster. But with our software in the middle, these two platforms can send data back and forth to each other. The third item on this list here is the notion of non-proprietary. We have a software-based solution. We're not in the data path. Users continue to access their data as they always have. And every file and every object that we write down to the various storage platforms that we support is always transparent and immediately usable. You do not need our software in place to interpret the data we're replicating. Finally, the last item on this list here is the notion of hybrid multi-cloud. It's kind of a combination of the first three items here. But the bottom line for this one is that between our real-time cross-platform and non-proprietary nature, we allow customers to pick and choose different storage platforms and different on-prem versus public cloud infrastructures to basically pick the best solution, the best tools that they need to help drive their business forward. So let's change gears a little bit and talk about Pure's relationship with Nutanix. It started about 3 years ago with the Nutanix Acropolis File Services team, now known as Nutanix Files. We've worked with them to design, implement, and integrate with what now is known as the File Activity Monitoring API. And this API is our real-time eyes and ears into what's going on inside of Nutanix files. You might notice that this API is now used by other vendors as well as Nutanix's own internal file analytics product. We've worked very closely with the Nutanix Ready team to make sure that our software is integrated and validated against all the different versions of Nutanix files that come out. So we spend a lot of time with those folks ensuring compatibility between the two product lines. And one important note I want to mention here is the notion that everything we're talking about today is in a SIFS SMB world, but we are working with the Nutanix Files engineering team to deliver NFS capabilities later this year. So stay tuned for that. About a year and a half ago, we also started working with the Nutanix Objects team. We worked on integrating our file-to-object engine in our software stack to be able to talk to their S3-compatible front end. We also, similar to Nutanix Files, we got that integration Nutanix Ready certified as well. So Nutanix Files and Objects are at the core of what we do with Nutanix. Now, I want to talk about a few use cases, key use cases we work on with the Nutanix team in the field. The first one I want to talk about here is the notion of active-active file sharing and collaboration. I just want to pause for 1 second on this phrase active-active. It's a term that gets used quite a bit in the storage industry. You'll see vendors talk about this as making independent data sets active in two locations, almost like it's a kind of a stretched cluster capability. But when Pure Software talks about active-active, we're talking about putting the same data set and making it active at multiple locations. So that concept powers this idea of file sharing and collaboration, and allows us to use our replication, our real-time synchronization capabilities with an added benefit of distributed locking to help deliver fast local access to project teams that might be distributed around the world, all working on the same files. So that's file sharing collaboration. We also have active-active data center synchronization on here. Similar to the file collaboration model, we're talking about synchronization between different storage platforms at different locations in real time. But the goal here is focusing more on end-user data, VDI, and profile data, and making sure that data is highly available across data centers or across cloud regions for your end users and your applications. The next scenario we have here is storage interoperability. In this scenario here, we will be talking about two flavors. There'll be the notion of phasing in or using Nutanix files in an existing storage infrastructure, as well as we'll discuss the notion of being able to translate between file and object formats. The last topic of discussion on the list here is analysis and migration. We have tools that help customers understand what's on their what unstructured data lives on their storage devices, whether it be planning for future migrations or for trying to optimize your resources. We have tools to help with that. And we also have tools to help drive minimally disruptive data migrations from legacy NAS to new technologies like Nutanix files. And that's all driven, again, by those real-time hooks we talked about earlier. Before we jump into the architectural diagrams, I just want to give you a quick overview of how our integration with Nutanix files works. We'll start off with Nutanix files deployed here, an AOS cluster. We'll have files deployed on top of it. And then we have a piece of software we call the peer agent sitting in a Windows VM on top of that AOS cluster. And the peer agent's job is to interact with the local API to hear what's going on and respond to those interactions. But its job is also to help facilitate replication from this location to other locations in the environment. So the way this works is the peer agent will reach out to the file activity monitoring API. It'll say, hey, I'm interested in monitoring these shares for activity. I want this type of information, and I'm available here. You can hit me at this IP address and this port number. So as users start to make changes to those shares on the storage side, the API will send those notifications to our peer agent. The peer agent will then reach back out over SMB to interrogate the data that was modified or added or whatnot, make sure it's still there, everything's there as we expect it to be, and then we'll use SMB to read that data and send it over the wire over our proprietary framework of peer agents and our peer management center, the PMC. Will facilitate that data being replicated to storage devices in other locations. So that's just, again, a high level of how our integration with Nutanix files works. Let's go ahead and jump into some architectural diagrams. First up, we'll talk about the notion of file collaboration. In this example, we'll have storage devices in London, Washington, D.C., and New York. We'll have AOS clusters with Nutanix files sitting on top of each of those. And then we'll also throw some public cloud infrastructure in there in any public cloud provider. We're going to layer our software, our peer agent at each storage device, and our peer management center, which acts as a centralized command and control system for the infrastructure. We'll layer those two pieces on top of the infrastructure. We'll get it all wired up. And then once that's done, we're doing real-time synchronization, multi-directional, between all these different locations. We have the notion of being able to add distributed file locking so we can protect users who will work on the same files in multiple locations. We can protect against version conflicts. And one other important note here is that when we actually synchronize a file between sites, we are doing it at what we call a delta level. We are interrogating and looking for the differences of that file between the locations and only sending those differences over the wire. So in this scenario here, we'll have users homed in on local storage in London, DC, and New York. And say you have an initiative to push more users into the public cloud, maybe with virtual desktops to help deal with an influx of demand for work from home initiatives. So in that case, in the public cloud, those user desktops can be homed in on some sort of file server up in the public cloud, like Windows or maybe a NetApp platform. The last piece we'll layer on top of all this is the notion of a global namespace, and this is driven by our integration with Microsoft DFS namespace. The cool thing about this integration point is that it provides a near zero RTO for your end users in the event of a failure. In the case of, say, your user and the storage device in London goes down, without any user or help desk or administrator intervention, the users will automatically be redirected from London to their next closest file server so they can continue to work. So it's built-in automatic failover with this integration with DFS namespace. So in this scenario here, we'll have a user in Washington, D.C. open up an Excel document. We'll get notified by Nutanix files, and then our agent will reach out to the other agents in the environment and say, hey, this file is open here. I need you to lock that file down at those other locations so that at this moment, the user in DC owns the master copy of that file. The other users can get read-only versions. They can still read what's inside the file data, but they won't be able to make changes to it as long as the master still lives in DC. So the user in DC makes some changes, closes that file. We'll get notified of all those activities by the file monitoring API. And the agent will facilitate the deltas being replicated to the other locations, and then we'll release our locks everywhere so that any user at any other site can now grab a master copy of that file. So this is file collaboration. Let's move on and talk a little bit about data center synchronization. In this particular example, we'll have data center infrastructure sitting in Washington, D.C. and Seattle. We'll have Nutanix files in both locations. We'll layer our software on top of this again, like we did with the collaboration model. But the difference here is that we'll have users who are accessing the data, they have primary access to one of the two locations. We'll add DFS namespace on top of that to bring a automatic failover route. And basically now, if there's an outage in Washington, D.C., as an example, users will automatically be redirected over to Seattle so they can continue their work. So the data here, user data, profile data, application data, is now highly available across different data centers. But it's not just between different data centers. It could be between an on-prem data center and the public cloud. It could also be between different cloud regions or even different cloud platform providers. Whatever your business needs are, we can help work with that replication topology. Next scenario here, we'll talk about storage interoperability. We'll start off with talking about our file-to-object capabilities. In this example, we'll have Nutanix files sitting in Washington, D.C. We'll have some sort of EMC device, maybe a Unity array out in London, and a NetApp ONTAP 9 array in New York. We'll then layer Nutanix objects, the on-prem object store from Nutanix. We'll layer that on and put that in Washington, D.C. And then we'll put our agent software again in front of each of these storage devices. The agent again will be listening in real time to what's going on these storage devices, but instead of replicating it to another NAS device, instead those agents are going to facilitate replication in a transparent fashion from enterprise NAS into object format in Nutanix objects. Important note here, again, every object we put in the object store is immediately consumable by other services that can speak object. You do not need our software to interpret the data that we're putting in the object store. We also have support for Azure Blob as well as Amazon S3. So if your business requirements need either of those public cloud providers, we can help pump data into them as well. And this whole file-to-object capability, we're seeing two primary demands for this in the field. One is the ability to do backup from enterprise NAS into lower cost object storage. We'll layer the ability to do snapshots, synthetic snapshots on the object store so you can do point-in-time recoveries if you need to. But we also have customers who want to just do a straight replication from enterprise NAS into some object store so that they can take advantage of the data they have on the enterprise NAS and be able to analyze it and work with it in a cloud-borne service, doing maybe cloud-based analytics or something like that. So just gives you the ultimate flexibility to have your data available to different services in different formats. Moving on in terms of storage interoperability, this particular chart here looks very similar to what we've already talked about, but the main thing I wanted to point out here is the notion that we have different storage platforms talking to one another, replicating, synchronizing data between each other in real time, as well as being able to push data in real time into object storage. So this just maximizes your flexibility. You can introduce Nutanix files in one location and still have it integrate into a backup or replication fabric, if you will, across the rest of your infrastructure. Let's talk a little bit about analysis. Obviously, analytics is a hot topic in the industry, in storage industry today, and it's also a hot topic for us as a company. We have a tool that we call a file system analyzer that sits as a simple install or simple application that runs on Windows, a Windows VM that's fronting some sort of storage device. And the way the file system analyzer works is it performs high-performance metadata scans of various volumes and shares and folder structures on your storage device. It rolls up a bunch of metadata calculations, it does a bunch of analysis on that data, and then emails out some very extensive Excel-based reports into your inbox. There's 30 or 40 different data points and charts that we show in these reports. But some of my favorite ones to talk about are, obviously we can tell you how many files, folders, and bytes are in your environment. That's fine. But one of the cool things that we support here, if you have users on volume, like if you have a volume that's focusing on user home directories, we can help you shed light on some users who might not be touching data anymore. Maybe they're no longer with the company. Data that you might want to archive off or move somewhere else. In this particular example, we had a customer with almost 50,000 user directories on a single volume, and it turns out 28,000 of them hadn't touched a file in over a year and weren't with the company anymore. So there's all this extra data that these administrators have to back up and replicate between locations that they really shouldn't have to. And it's also taking up valuable space on their primary storage. One of the other charts that we show up in these reports is a notion of rolling up different types of extensions and understanding what type of applications might be running in your storage environment. I love to ask customers, how many applications, how many extensions do you think you have in your environment? And they'll often say, oh, about 200 or 100 or whatever. And we go and run our tool and we turn up 80,000. For a storage admin, they have no idea. There's so many people, so many applications writing to their storage that it's hard to keep tabs on what's going on to the storage device. And the file system analyzer helps shed light on some of that. Lastly, one of the charts I like to talk about is this notion of analyzing files by their last mod time and rolling up totals to give you kind of heat maps of what times of days of the week, what times of the year, what months of the year, what what hours of the day are most prominent for users to make changes in your environment. This happens to be a customer of ours who does tax software, and you'll see there's a peak in March, April during the spring tax season, another peak in the fall tax season as well, and that second chart down on the left. So just very cool telemetry on how your storage is being used. Finally here, let's talk a little bit about migration. We're going to go from a legacy NetApp device, move to a Nutanix files array. We're going to throw in there what we call our PureSync server. That basically runs on a VM that fronts the source storage device. You can have one of them, you can have multiple if you want to try and parallel process the migration to speed it up. But the way this PureSync engine works is it'll do an initial scan and seed of the data to the new storage device. That'll then register with the real-time API on that storage device so that as users are making changes to that source device, the API notifies us and we're able to replicate those changes in an ongoing fashion to the destination. The cool thing about this is that when you get to your final cutover window, there is no final scan required. You cut off access to applications and users to the source. You let PureSync finish handling anything that might have been opened or that's still in flight. And once PureSync's queues are all emptied out, you're ready to move over to your new storage device. Simple as that. All right, so I just want to wrap up here with a couple of key advantages about our integration and our work with Nutanix. First off, I just want to point out again that everything that we do is non-proprietary. Everything that we do is non-proprietary. Every file we write, every object that we write down is always transparent without our software, whether it's in file or object formats. We also want to talk about the notion that you don't need to lift and shift if you want to introduce Nutanix files. You don't have to rip the entire environment out. You can phase it into an existing storage environment. We also want to hammer home the point that with our replication technology, you have active data everywhere so that in the event that a user, there's some sort of storage or network outage, users can continue to work and applications can continue to work on their data with a very low RTO with that integration with DFS namespace. And finally, here I have a note about using Nutanix files with active data everywhere. We're not some sort of cloud file system or whatnot. We're using Nutanix files as it is, putting active data everywhere on it. And it's not a dumping ground. It's active, and you're able to take advantage of all the benefits of Nutanix files for your environment. So with that, we have this last slide here with some resources, how to reach out to us, how to communicate with us. If you're on the Nutanix Slack environment, you can reach out to this Pure Software channel or hit me up directly. And with that, I just want to say thank you for attending the session today. I hope you found it valuable. Please reach out if you have any questions. And again, thank you for attending.